Hello friends, so today we are going to see the topic that is characteristics of an operational amplifier. So we are going to talk about an ideal operational amplifier. So we know that we already saw this is an operational amplifier which has two input and there it is only one output. So when we talk about an amplifier, the main part of an amplifier is that is a voltage source which increases in relation to the voltage drop across R in, and thus amplifying the voltage difference between positive terminal, here it is a positive terminal and here it is a negative terminal. This is inverting terminal, this is non-inverting terminal. So here we can see that there are many uses of operational amplifiers are there. Now we talk about the ideal characteristics or characteristics of an ideal operational amplifier. So see, here it is. Let us consider standard operational amplifier equivalent circuit. So here we know this is an operational amplifier which has two inputs. One is called as a non-inverting, which is denoted by positive, and another one terminal is called as a inverting, which is denoted by the negative terminal. So here we are giving input to a positive terminal, which is we call it Vp, and here the input voltage given to the negative or inverting terminal, that is called as a Vn. So here this is a input and there are two input terminals. So there it is a resistance between two input terminals, that is called as a input resistance of an operational amplifier. So when we talk about an input resistance of an amplifier, that is resistance between two input terminals. So remember that when we talk about the Opamp, so this is first input terminal, that is negative, this is another second, these are input terminals. So here we are going to connect, say here it is Vn or here it is Vp and here it is Vout. So whenever we talk about internal resistance, it is between these two input terminals, that is Ri. So here it is, Opamp has only one output, that is Vo, and here it is the resistance at the output, that is called as a output resistance. So Opamp has input resistance as well as output resistance, and this is the gain. So remember that input that we know, that is Vp for non-inverting terminal, Vn for inverting terminal, and there it is an output, that is Vo. So how much is the output? So remember that Vo is equal to Vp minus Vn. So that is, remember, this is Vo, that is output voltage, which is basically a difference between non-inverting terminal and inverting terminal. So that you first remember. So let us talk about an ideal Opamp, its equivalent circuit and its characteristics. So in this figure show here, it is Vp is a input to the non-inverting terminal and Vn is the input to the inverting terminal. So observe carefully that between these two input terminals, these terminals no resistance is shown. That means here resistance, that is Ri, between this positive and negative, that is infinite. So input impedance is infinite in case of ideal operational amplifier. Similarly, in earlier case where we have shown, here it is Ro, that is output resistance by this resistance symbol, but in case of ideal you see that the directly wire is connected, no resistance is shown. So we can say RO is 0. So these are the most important characteristics for any amplifier, that its input impedance is infinite and output impedance is 0. So here it is another characteristics of an operational amplifier, that is infinite open loop gain. So see what is gain, let us consider. See here it is gain. See here, if this is an amplifier, so this is input terminal, that is V in, and here it is output. So AV, that is a voltage gain of an amplifier, this is an amplifier, is basically AV is equal to VO upon V in. But here when we talk about operational amplifier, so operational amplifier has, this is non-inverting terminal which has, suppose input voltage, let us consider VP, and this is non-inverting terminal which has input voltage Vn. You may call it V1, V2, etc. And output voltage is VO. So now operational amplifier has two input terminals or two inputs. It is not like this amplifier. So actual input is Vp minus Vn. So that is difference of two input voltages is an input, and therefore voltage gain in case of operational amplifier AV is equal to VO, that is output voltage, divided by Vp minus Vn. Remember, in some book it is called as a V1, it is called as a V2. In that case you will see that VO is equal to V1 minus V2, etc. So that is the gain of an amplifier. Now here in case of an operational amplifier, this AV, that means gain is infinite. Okay, so that is AV, but it is, remember that, open loop, that is infinite. That means though very small voltage is applied at the input, the output voltage is very high, that is infinite. This is in case of ideal amplifier. So that is the characteristics of an operational amplifier. So here figure shows that at the input end there it is no connection between inverting and non-inverting. That means there is an infinite resistance at the input, so input impedance is infinite, that is open loop. So here we see that the resistance between this and this terminal is infinite, and if this terminal resistance is infinite, the current is 0. Remember, it is very important thing to know that in case of ideal amplifier, input impedance is infinite, and that is why input current flowing between this terminal is 0. So similarly you see that output impedance is 0. So here it is, since remember that this is an operational amplifier in which this is one input terminal, this is another input terminal, say it is inverting, this is non-inverting. So as the resistance between these two terminals is infinite, the current flowing between this and this terminal, that is input current I, is equal to 0. So there is no leakage or bias current into the device. That is most important thing related to ideal operational amplifier. So see, since Ri is infinite and voltage difference between Vp and Vn is equal to Vi is finite. So that is important thing. The input currents are 0 for an ideal operational amplifier. So the input current I is equal to 0. Then infinite bandwidth. So remember that whenever we are applying input signal to these terminals, so these signals may have the frequency range between 0 to infinite. That is, infinite bandwidth means though we change the frequency of the input signal, the gain of amplifier remains constant and the response is same for all frequencies, and that is why the most important characteristics of an ideal amplifier is infinite bandwidth. Zero input offset voltage. So we already saw what is input offset voltage, that whenever we connect the power supply and both terminals are at the same potential or ground potential, it is expected that the output should be 0, but actually we are not getting it. So that means we have to make changes in input such way that using offset terminals such way that the output will be 0. But for an ideal operational amplifier, there it is a 0 input offset voltage. That means when both terminals are ground, output voltage is exactly 0. So that when the two input terminals are shorted, so that Vp is equal to Vn. So when both voltages are same, the output is said to be virtual ground. So we are going to see the virtual ground concept in details later on. So remember the characteristic: 0 input offset voltage. So next characteristics: infinite slew rate, that is rate of change of output voltage is unbound, that is full voltage and current available at all frequencies at the output in case of ideal operational amplifier. Next one is zero output impedance. So we saw that resistance between these two terminals, it is called as a input impedance. So similarly, here it is at the output end, there it is a resistance that is called as a R out or output impedance. So here the output impedance of an ideal amplifier is 0. Remember that there is 0 resistance at the output. So that you should remember. So there is no, the purpose of this, when the output resistance is 0, that means whatever output current is delivered by the operational amplifier, that full current flows or is given to the load resistance. So no loading takes place. So see, there is no loading effect at the output part of an ideal amplifier, and therefore output voltage VO is exactly equal to gain times input voltage Vi. So again, in case of ideal operational amplifier, the noise is 0. So whatever noise present at the input, it is cancelled at the output, and so no noise signal gets amplified at the output. This is the most important characteristics of an ideal amplifier. Next one is infinite common mode rejection ratio. So see, we already saw that it is the ratio of the differential gain to the common mode voltage gain. So see, this is an operational amplifier. These are two input terminals. If the same voltage is given to both the input terminals, that is called as a common mode. And if the input at inverting and non-inverting terminals are different, then the difference is given, that is called as a differential mode. So CMRR is gain with differential input to the gain with common mode. So where ACM, gain is V out upon V common mode. So here it is V common mode is output common mode voltage, and VCM V in, that is input common mode voltage. Ideally common mode voltage gain is 0. Hence ideal value of CMRR is infinite in case of ideal operational amplifier. So next characteristic is that infinite power supply rejection ratio for both power supply rails. See, we already saw that is power supply rejection ratio, that is, it is the ratio of change in input offset voltage to the corresponding change in one of the power supply voltage provided all remaining. So here we know that there are two supplies provided. See, one of them is changed, there can be a change in input offset voltage, but in case of ideal operational amplifier, infinite power supply rejection ratio for both power supply rails, that you remember. So let us consider negative feedback. Now the important thing to know that in case of operational amplifier, okay, here it is inverting terminal, here it is non-inverting terminal, and we know that what is meant by feedback, that you first remember when we are talking about negative feedback. This is input side, this is output side. Some part of the output is given to the input side, that is called as a feedback. So when this feedback is given to inverting terminal, it is a negative feedback. When this feedback is given to positive terminal, it is called as a positive feedback. So that you should remember. So here, in case of negative feedback, no current will flow into the inputs. So remember that it is clear that input impedance of the operational amplifier is infinite. So remember that no input current flows, that is important thing. So whenever feedback is given, so here input terminal means this is one input terminal, this is another input terminal. Remember that whenever we apply Vn here, when we apply Vn here and we apply Vp here, so here Vn and Vp are the outputs, here also output. These terminal points are called as the input terminal. So whenever we apply negative feedback, no current will flow into the inputs. The input voltages at two terminals will be nearly equal. So here whenever we apply Vn and Vp, in case of an ideal operational amplifier, the gain is infinite. So that is why infinite voltage appears across the output. But whenever we provide some part of the voltage through a circuit or feedback resistance, here it is, you can say when we apply here it is Vn, so it has input resistance, so here it is Vn and here it is Ri, this is Rf. So now whenever the part of the output voltage is fed to the input, automatically affects the output voltage because of input changes, and slowly Opamp stabilizes the thing in a such a way that the voltage at this point is exactly equal to this point, and that is why when both terminals are at same potential, there is no current flowing between this inverting and non-inverting terminal. So the input voltages at two terminals will be nearly equal. This is a concept of negative feedback. We'll see while considering virtual ground in detail. Then open loop gain is infinite, that we already saw, that is gain is equal to V out upon V in. So these are the ideal characteristics of an ideal operational amplifier. Okay, thank you.